A taxonomy of on-demand offerings. There are lots of different types of clouds. I'm going to try and clear that up a little bit for you. The first kind of cloud, broadly speaking, is something called infrastructure as a service. Infrastructure as a service is pretty much I rented a virtual machine. Every private cloud that you know is running on something like Xan or KVM or VMware or Hyper-V is basically running an infrastructure as a service cloud. If you go and rent a machine, if you can see where the sausage is being made, so to speak, then you're renting infrastructure as a service, usually a machine by the hour. This is the common model that Amazon uses. So you basically get a menu and you set like a small, medium, or large. It's very much like going to In-N-Out and ordering a burger. You're ordering a machine. It's very simple tiers and so on. And this is where it's very good to parallelize tasks. So in this case, the Washington Post had a substantial number of of documents from Hillary Clinton when she was running for office. And because they were able to take that task and break it up across 200 virtual machines and use them for a day instead of giving that task to one machine for 12 days, they got their answers more cheaply and they also got their answers sooner. Cost them a total of $144 to do this. For an 11-day scoop on the other news organizations. It's a pretty good trade-off. This is where you've got virtual machine instances that you spin up. So here's how infrastructure as a service works. Virtualization is the ability to take a machine and park it. So here's a web server running as a virtual machine on a physical machine. It's an instance. It's called an instance of a machine. Now, because that's a virtual machine, I've got an image of it. It's a copy of that machine, its memory, its file system, and so on. And basically, I can tell that machine to go away. I still have the copy, right? So if I want to create an application tier, I go, oh, OK, here's that image of machine, just like I'm hibernating a computer. And I go, great, I've created a new web server running on some hardware somewhere. And then I've got an image of a machine that's an application server, let's say WordPress. And I've got an image of a machine that's a database server, let's say MySQL. And so now I've got a web server, Apache. I've got an app server running on a separate machine in this case, would be like WordPress, and then a database server. And any three-tiered application kind of looks like this. And that database server probably has connections to some other third-party storage. So it keeps its data somewhere else, just like you'd have things on a storage area network or a network-attached storage. So this is a three-tiered infrastructure as a service application. I can see 3 tiers of stuff. Each of them is a virtual machine running on a physical machine. Well, why is that interesting? Because if I want a bigger machine, traditionally, I do what's called scaling vertically. I go get a bigger database. This is why someone sells me a big database with lots of memory. That's one way of making things bigger. But in a cloud model, I can take that entire stack of things. Remember, these are virtual machines, so I just copy and paste. I create another copy of them. Now I have twice as many machines. I've also got resiliency, right? I put a load balancer in the middle that will share the load across the two of them. And if any one of these two stacks dies, things keep working. And that's how we build reliable, scalable web applications. This is an infrastructure as a service model. The other cloud model is platform as a service. Platform as a service is things like Google App Engine, Salesforce.com, and so on. And in platform as a service, it's a different model entirely. You've got your code. You have no idea whether it's running on one machine or 100. You don't care. But you've got your little code, your little program you wrote that says hello world or whatever. And it's on this big processing platform with everyone else's code. So I take my code and I paste the text, almost, into Force.com or into App Engine, and it runs. Now, there are a bunch of calls I can make. So I may have an API that I call. I write a piece of code and I say, please store this object for me. I don't write to the disk. I don't know whether there's a disk. I just say, please store this object. Or I say, please check if this user is legitimate. Please rotate this image and crop it for me. Please store this large video object. These are API calls I make. I have no idea how many machines I'm on, right? That other model, I knew how many machines I had. Here, I don't know. There's a thing called a governor, which makes sure we all play nice. So if my code is really inefficient, it may go, whoa, your code's taking too long. I'm going to kill that task, because otherwise it'll disrupt the rest of the system. There's a console that shows you what's going on, because it's a utility. I know everything you're doing. I'm going to show you. And there's some kind of a schedule that says, OK, now it's your turn to run. Now it's your turn to run, and shares the resources equitably. It'll also do things like start a new process at 5 in the morning because you've told it to, things like that. Notice how different this is from the infrastructure as a service model. It's my code and other people's code. I don't care where it runs. I also don't have to worry about where it runs. If I get twice as much traffic, this platform just deals with it. I don't have to go create another virtual machine. So in the long term, most people who look at clouds think this is where the computing world is going, that the infrastructure as a service stuff is just a comfortable, convenient halfway mark towards true processing like this.